First, we briefly go through the yesterday class. Okay. So first, we have seen we have in the application two kind of threads we can create. One is main thread, one is a background thread. So any application will have only one main thread. If I want to create a thread through this class, through the dispatch queue, I can create a main thread, I can create a background thread. Now, in a thread, what kind of operation I can perform? I can perform serial operations, I can perform concurrent operations. Serial operation, if I have three functions, one by one it will be executed. And in concurrent, all the operations will be executed parallelly, and the result depends on which will execute first, that will provide you the result. And when it comes to our application, my Xcode, whatever it is there, it will create only one thread, and that particular thread is a main thread. Okay. So whenever we say main thread, not only here, anywhere, whenever we say main thread, it is always a serial operation. So in the dispatch queue, we have created a thread. So yesterday we have created a thread. On a particular thread, we have seen synchronous operation, we have seen asynchronous operation. When I say synchronous, so here we have a output, so it is running in the main thread. When I perform asynchronous operation, it says it performed in a background thread. And the difference between main and background, main thread will always block all other threads, and background thread will never block any thread, it will perform in the background. Apart from creating my own thread, I can create a global thread. Through the global thread also, I can perform a synchronous operation, I can perform a synchronous operation. And after that, we have a main thread. In the main thread, I can perform only asynchronous operation. If I perform a synchronous operation, my application will get crashed. So these are the things we have seen yesterday to create a thread and all this. But when I say operations, we have two, serial and concurrent. By default, dispatch queue will provide a serial operation. What if I want to make concurrent with dispatch queue? If you want to make concurrent operation with dispatch queue, you provide attributes for that. So whenever you're creating a thread, you create attributes for that, and we have two kind of attributes. One is concurrent, so now the thread will be the concurrent thread. Now the thread is no more a serial thread, it is a concurrent thread. And another one, inactive thread. I want to create a thread in inactive state. So later I will make it active and I will execute the thread. So in these cases, we can use concurrent thread and inactive thread. And after that, if I want to provide a delay for a thread, I can provide a delay by telling the time. How much time I want to do the delay, I can do the delay. And after that, if I want to provide quality of service for particular thread. So we have 5 levels of quality service. So we have background, utility, default. I'll copy this. These are the 5 levels of priorities we are having. One is background, the least priority, on top of the utility, on top of the default, user initiated, user interactive. Always user interactive will high priority. So this we have seen only for the dispatch queue. Now we'll see one more class. So this is the thread class which will provide to create a thread. And now we have one more class called operation queue. Like dispatch queue, we have operation queue, and operation queue by default it will create a concurrent threads. So it is just opposite to dispatch queue. Dispatch queue by default a serial, operation queue by default a concurrent. Now we'll see how to create a operation queue. I'm creating a function thread operation. So here I want to create one thread first. Like in the dispatch queue, how we are creating a thread. The dispatch queue, this is where we are creating a thread. In operation queue, okay, there is no name provided, so only a class I can initialize, but I cannot provide any name here. So this will create one thread for you. So this is nothing but thread creation for operation queue. So this is for dispatch queue. Here, how I can add the function. Here I am directly creating a thread, I am performing the action, but in operation queue I cannot directly assign the operation. Here the first thing, you have to create a operation for this. Create operation and add this operation to your queue. How I'll create an operation? Here we have two kind of operations. One is block operation we can create. One is invoke operation, but this invoke operation will not be supported in the Swift language. So here we will not use invoke operation. This is Sukant, are you able to see the screen?
No, actually, it's not there.
I think
Actually,
only
I'm
one
on that.
screen you have shared. Maybe that is the reason. We
No.
are still stuck on threads 2 types, operation 2 types.
Okay. Let me stop and start again.
Sure.
You're able to see the screen now?
Yes,
Yes.
not.
So now I have created a block operation and invoke operation. So you are able to see the block operation, invoke operation, right?
Yes.
Right.
Okay. So in the operation queue, what happens when I create an operation queue? By default, it is a concurrent. So in the dispatch queue yesterday, by default, we said it is a serial operation, but operation queue is just opposite to dispatch queue. It will create a concurrent thread. Now in this operation queue, I have to create the operations. This operation I have to pass to the queue. Then only it will be executed. So what kind of operations we can create? We can create a block operation. We can create a invoke operation. But invoke operation is only for Objective-C. Here in Swift we cannot create. So what we can create? We can create only a block operation here. So first thing, I have to create a block operation. Operation 1 variable I'm creating. So here whatever we are saying, we are just creating a variables. We are not doing anything. We can create either using let keyword or a var keyword. So in dispatch queue, whatever we have used either let or a var. So I want to create a block operation. Block operation got created. So how I will execute this? So block operation initializer you have to do, just add your block here and write your code. What you want to write, you write your code. So this is nothing but creating the block operation. And here I'll write, I want to print apples, I'll print apples. Number of operations we can create. So how many operations you want to create? You can create number of operations. If I want to create one more, operation 2, now I have created 3 operations. Now the operations what you have created, you have to add to your queue, then only it will be executed. If you're not adding to your queue, it will never be executed. My operation queue, dot add operation. So what operation you have created, then only it will be executed. If you are not adding operations to your queue, it will never be executed. I want to add all the operations. The first step, I am creating a queue here. So this is nothing but my thread. Here, this is not the thread. This is the thread we are creating. So one thread we are creating. To the thread, we are adding the operations. Here, till this point, we just created an operation. We have created a queue. We have created an operation. Now, in the next step, we are adding this operation to the thread. Then only it will be executed. So as we discussed, it is a concurrent operator. So whenever you create a thread, by default, operation key is a concurrent. So all together will be executed. Now it may be the result. The next time the result may change. So the result got changed. So whenever here we are not sure about the result, so whoever finish the task first, that will provide you the result first. So now I will get a result first. This is how we create a simple operation queue thread. So this is little different from GCD thread. When we are having GCD, why? So this we call as a GCD also. Forgot. It is nothing but it is grand central dispatch. So you may get a question GCD or operation queue. So dispatch queue, GCD, grand central dispatch, everything is same. Now why it is different from GCD? So going forward we'll see. Now I have created a thread, it is a concrete. Now I want to make it serial. Because I don't want to execute all together. Here what happens, whatever I'm doing, everything is executed parallelly. So my output I'm getting parallelly. Now I don't want this kind of scenario. What I want is, first I want to print apples, one it is printed, then this, one it is printed, then this. Nothing but some serial operation. For this, what I have to do, you have to add dependency between the threads. How I will add dependency? So first, this control is getting executed. Control will come here. It is adding the operation. Okay. Now, before executing operation two, my operation two, I want to add some dependency. For operation two, I am adding dependency on operation one. So this line of code, what it will execute means, once operation one completes, then only operation two will be executed. Why means, for the operation two, I have a dependency. What is the dependency? Operation one should be completed. If it is completed, then only it will be executed. If for some reason in the real time, if this is not executed, your operation two, operation three will never be executed. Once after successful execution of this will be executed because of the dependency. The same dependency for operation 3, I will add dependency for operation 2. It doesn't mean once operation 2 completed, then only operation 3 will be started, or else operation 3 will never start. So first my operation 1 is completed. Because of the dependency, operation 2 will wait. So here we are adding everything, but operation 2 wait because of the dependency. So now operation 2 is getting executed. Still operation 3 will wait because of the dependency, then operation 3 will be executed. So every time you will get the same output.
If we add dependency in one, we have to add it in all.
Before
Or
that, yeah, before adding the operation, you have to add the dependency.
no, is it necessary? We can't keep like two concurrent operations and one with dependency.
Yes, we can create. So here I don't want to I don't want any dependency for operation 2. So now here in this case what happened, these two will be executed parallelly and operation
Okay.
3 will wait for operation to complete. Here
And same thing will happen if we give dependency on operation 1 to both. So then
correct.
it will be completed.
Yes, yes, yes. So now
And does these threads gives any responses?
yes, I'll
I
show you
will
that.
complete.
Yeah,
Okay.
yeah, the responses
Perfect.
next we'll see. Now here I don't have any dependency for operation 2. So operation 1, operation 2 I'm adding and there is no dependency. So this got executed, but for operation 3 I have a dependency. So it is executed late. Now by default what are the thread you create? It is a background thread. So operation Q, we are creating a background thread. So always it will be executed in the background thread. Now I want to make a main thread. I want to execute this operations in the main thread. So your operation queue, if I want to create a main thread, you create a main thread. As dispatch queue has options like giving a name, giving a global queue, giving a QoS, giving a attributes, or giving a thread delay. These options I don't have for operation queue. So what are the options we have seen? We don't have any options. Either you create a background thread this way or you create a main thread this way. That's it. We don't have any other options. So main thread, as we know, you don't need to add any dependency. It is always a serial operation. It will always block other thread. Here, if I see, I commented my dependency. Here also I commented my dependency. All three operations we are adding to the operation queue. Still, because of it is a main queue, it will execute in the main thread and one by one it will be executed. Number of times you run, it will be always one by one. So this is how we create a main thread, and for background thread, this is a background thread, this is a main thread. Any dots still here in the operation queue? Okay.
No.
Okay. Now one drawback which is not there for the dispatch queue and which is there in the operation queue. Completion blocks. Here you are executing the thread, it is getting executed, but I don't know when it is getting finished. Here this is getting executed, I am getting the output, but there is no response when it is completed. But for operation queue, we have a completion block. If I am running this operation, if I want to know when it is completed, so to your operation, you can add a completion block. What do it mean? Means when operation 1 completed, it will give you callback here. Operation 1 completed. The same way, how many operations you are having, to all the operation you can have a completion block. So as we said, main thread one by one it will be executed. So once it is completed, I am getting a callback. My operation 1 is completed. So I am printing the message. Once this is completed, operation 2 complete. Once this is completed, operation 3 complete. But if it is a main thread, we know one by one it will be executed. I don't need completion block. When it is a concurrent, when it is a parallel queue. So here altogether I'm getting the message. First operation 3 got completed, then operation 2 got completed, then operation 1 got completed. So in the parallel, if you want to know when it is getting completed, you just add operation queue, add operation. But in the dispatch queue in the GCD, we don't have any callbacks. Here we have to go for dispatch group. There is a worker item again, dispatch group. You have to lock your thread. When I'm executing this, I have to lock this thread. Then only I'll come to know whether it is completed or not. But in that cases, when there is a requirement, you want to know about your operation, go for operation queues. If not, go for GCD. Now, one more thing. Here, if I want to provide quality of service, for the GCD, we have a quality of service. For operation queue also, we have a quality of service. The same levels that are available, which is available for the GCD. So, what kind of priority you want to provide? Because here I have only one thread, so I don't need to provide any quality. If I have multiple threads, then you provide your quality of service. So what kind of quality you want to provide for this? Now after this, once I execute something in the GCD, now this is a GCD thread, I'm adding some operations to print apples. Once this is started, there is no chance I cannot stop this operation. At any cost, this will be executed. I cannot stop this operation. The same way, at any point of time, from the GCDs, you create any thread. If you started executing, there is no chance of stopping it. But using the operation queue, if I started some thread, if I want to cancel this, I can cancel the operations. This is one more advantage from the operation queue. Operation 1, I can cancel. So any operation, if you want to cancel or if you want to stop and start, to check whether it finished or not. So we have so many states here. So you can cancel the operation, you can start the operation, or if you want to cancel all the operation to the operation queue, suppose I have added 100 operations. I want to cancel all this. Your operation queue, you can cancel all the operations. So all the operations what you have executed will be cancelled. So why I need to cancel this? So there is some real-time example. If interviews, if you get a question, tell them. If I launch application, in the first screen, and after launching the application, I have to show some image to the user. So when I'm showing that image, from where I'll get it? So suppose the image you are getting from server. Some image I'm getting from server. If I want to show that image, I have to download it. So when you are doing a download operation, you do this operation on particular thread. You use either the operation queue thread or you go for the GCD thread. So some thread you are creating. As of now, we'll say this is a X thread. You are creating X thread. Before downloading, so it may take time here. It may take 5 to 10 seconds to download the image or to show it to the user. In between this 5 to 10 seconds, user is going to different screen. From first screen, is going to the second screen. In this case, what happens? The image you are downloading the first screen. Anyway, if he is going to the second screen, he cannot see image here. When he is not seeing image here, you don't need to download that. So if you still download, it will consume your data. So now, whenever he is going to the second screen, here I have to cancel that download. So whatever you are doing the download, I have to cancel the download to save your data. If I use GCD here to download the data, here anyway I cannot cancel, it will be downloaded. If I am not seeing also, it will be downloaded. If I use operation queue here, I'll say cancel the operation will get cancelled, so the data will not be downloaded. If you see some Facebook or some other things, when you want to download, you can download. If you want to cancel, you can cancel. If this kind of operation will be executed on the operation queue thread, the other operations will be executed on the GCD. When it is having more options, operation queue is having more options, then why we need to go for the GCD? Because the performance will be high for the GCD threads. The performance will be low for the operation queues. When compared operation queue with the GCD, it will perform little slow. You may get a response little slow. And here the performance will be high. That's why people will go for the dispatch queue. But according to the requirement, you have to choose what kind of thread you want to give. Here it's not like always go for the GCD. If this kind of task comes, you have to choose very clearly which kind of thread you have to create and what operation you want to perform. And the major difference, the dispatch queue, whatever we have seen, it is a class. Dispatch queue is a class, but as per our knowledge, we can subclass anything. We can inherit from anything. Suppose I want to inherit from dispatch queue class. It will always throw the error. Nothing but you cannot subclass the dispatch queues. We cannot subclass GCD. This is a disadvantage. And what about operation queues? Operation queue is also a class. I can subclass my operation queues. And you can subclass operations also, not only the operation queues. So why we want to subclass? If we want to override something, if we go operation queue here I have some functions, add operations, operation code. If I want to override these things, I can override these things. And you can subclass operation also. So what are the operations you are creating? Here you are creating some operations. If I want to override this operation, you can override, you can subclass your operation and you can override. So this is the major disadvantage. So if you get a question, what are the differences between GCD and operation queue? First, tell them this point, we cannot subclass GCD to override the operations. Here we can subclass operation queue and operation. In the GCD, we don't have completion blocks. We don't know when it is completed. And in the GCD, we cannot cancel the operation. So the rest of the things will be common for both. You can create a serial queue, you can create a concurrent queue for both. If I come here, you can create a main thread in the GCD and in the operation queue. You can create a background thread in the GCD and operation queue. Here, for both, it will apply. So here, there is no disadvantage. Here, serial queue using the both, I can create. Concurrent queue, I can create using the both. Now, this also, there is no disadvantage. Thread delay, I cannot give using the operation queue. So this is only for the GCD. And quality of service, I can provide for both. And cancelling operation here, I can cancel the operations, I can have a completion block, I can provide quality of service. So these are the advantages, some advantages are there, some disadvantages are there from the two threads. But real time, just go for the GCD. So the performance will be high, you will get a output easily. So this is entire thing about the threading concept, and apart from this, we don't have any other class which will create a thread for you. So only we have two classes which will create a thread for you, either GCD or the operation queue. Any notes in this? Nikhil, Sukant, you have any?
Array can be passed in the operation queue list.
Sorry?
Like you have in the add operation case,
Okay.
you have added individually, we can pass the array of type operation. No?
Yes, we can take operations into one array that we can pass.
Okay.
And here you can say how many operations you want to give for the thread. So when I go to operation queue, can provide what is the maximum operation count also. If I have 10 operations, but I want to limit my thread to 5 only, I'll give 5 operations. So what is the operation count you want to give? You can give the operation count. And if you want to pass array, here we have a array here. So operations, and it is kind of array with operation.
That's it.
Okay. Any other doubts in this? But if you don't practice this, if you don't idea about this, so you don't need to go for interview also. Just the questions what they ask mainly on the protocols, and the second thing mainly on the threading concept. So there is no third concept even. Third option, third concept, you may get a question. Either protocols or the threadings. Threadings, maybe the full interview they can take on the threads only. So how we create a thread? You may get a task to execute all this. Even JSON and so online server storing and code data, it is a little less concept. So when compared to these two protocols are this, So just one set of code that you can copy paste anywhere, it will work. Even the JSON code, if you copy paste in any for any API, it will work. The same way, core data, you just copy and paste method, it will work anywhere. But here you have to write a code. So this part is common. So creating a thread, this is one line of code, it is common. But executing the operations, how you have to execute, you have to create either a main thread or a background thread. And if you want to give priority, so all this you have to decide and you have to provide. So think in this, practice this more and more. So Nikhil, I'll stop the share and I'll share it again.
Okay.
Okay.